Hello everyone, this is N Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. So today's topic is interfacing with advanced devices. So coming to the overview of today's presentation, so what is serial communication, why we are using serial communication, and what are the data transfer schemes in serial communication like asynchronous communication and synchronous communication, what are the serial communication standards, and prescribably what is RS-232C serial data standards. So coming to the serial communication, as I already told in the previous video why we are using serial communication. So here to transfer the data bit by bit, we are using serial communication. Basically in microprocessors, the communication which we are using is a parallel communication. Then why we need to learn serial communication? So by using parallel communication for specific applications it is okay, but the long distance communication, the serial communication will plays a vital role. So here in serial communication depends upon the data transmit and receive methods. There are three types of modes will be there. So for long distance data transmission, parallel communication becomes impractical due to its highest cost and the cabling costs. So serial communication plays a vital role in long distance communication. And based on the transmission modes, the serial communication has been divided into three modes: simplex mode, half duplex mode, and full duplex mode. So coming to the simplex mode, so the transmitter will transmit the data and the receiver only receives the data at a time. So the transmitter once send the data, that data will be received by the receiver. That's it. At particular time only transmission and reception will be takes place. So example is computer sends the data to print for the communication, printer communication. So this is the one of the simplest example for the simplex mode. So coming to the half duplex mode. So here the transmitter can transmit the data and receiver will receive the data. And again the receiver also transmit the data. So and the transmitter can receive the data. Both communication will be possible, but not at the time. Not at the time. So at particular time, the transmitter can send the data and receiver can receive the data. After that, the receiver can send the data and transmitter, but not at a single time. So here one of the example is walkie-talkies, which some of the police is now using these walkie-talkies. So coming to the full duplex mode, where we are using now the serial communication, which we are using here is a full duplex mode. In USART, Universal Synchronous Asynchronous Receiver Transmitter, also uses this full duplex communication. As there we have seen asynchronous mode of communication, synchronous mode of communication, as USART 8257 can support both synchronous and asynchronous communication. Here in this full duplex mode, the transmitter can transmit the data and receiver can receive the data. Vice versa can happen at particular single time. Like we are using mobile phones, telephones, which we can send the data and as well as we can receive the data at the same time. So the USART which we are using in interfacing with 8086 for the communication purpose will support the full duplex mode, and it can works in both asynchronous and synchronous communication also. So coming to the data transfer schemes. So based upon the data formats, how we will send the data in formats, there are two types of data formats. One is asynchronous data and second one is synchronous data. So here in asynchronous communication, data can be sent without any clock. So instead of depending upon the clock, here in asynchronous communication, the transmitter and receiver will work on the synchronization by using start and stop bits. So if I want to send 8 bits of data, like I'll be taking 10010011. If this is the data, this will need to transmit from the transmitter and will be received by the receiver. But there is no clock signal to start the operation. So what we will do? We will transmit the data. The transmitter will add start and stop bits. The transmitter will add start and stop bits. So whenever the transmitter add along with start and stop bits, transmitter can add parity bits, depends upon the error detecting. If we want to find the error, if any error is there in transmission and reception, then you need to find out the error, which bit has been sent as an error. So you can add parity bits. So the transmitter, while sending the data of these 8 bits, it will add one start bit, one stop bit and one or more parity bits to that particular 8 bits of data. So it will basically become 11 to 12 bits of data. So these total bits will be received. So received by the receiver whenever the receiver received the start bit, then it will decode the remaining bits and it will wait until the stop bit. So if the receiver receives the stop bit, so there ends the reception of the data. This is how asynchronous data transmission will work. As here we are looking into the asynchronous data transmission timing diagram. Here, while starting, the transmitter will be in the ideal mode, like it will have 1. So it is having the high data line mode, which is 1. So unless this ideal mode will be moved to lower, so then only the transmission of data has been begun. So coming to the transmission mode, so the transmitter will send start bit as low bit, means 0. So if the 0 bit has been started, then next the data will be moved. So this data will be moved from LSB. The first data transmission will always start with the least significant bit and ends with the most significant bit. So the least significant bit will get transmitted and the next one. Likewise, until the most significant bit will reaches, the data transmission will be done. Next, coming to the stop bit. So the stop bit will always be the high bit. So if the 1, after sending the start bit, the data will be moved, and after moving the most significant bit of data, the stop bit will be generated by the transmitter. So transmitter will send 1 as the stop bit. Then here ends the transmission. Now the receiver first checks whether it is having the low bit. So if the low bit is coming, then it can start the reception of the data. After getting the start bit as low bit 0, send next 8 bits will be the data bits. So receiver will receive the 8 bits from least significant bit to the most significant bit, and until it finds the stop bit, after 8 bits the stop bit will come. If we didn't add the parity bits, if the parity bits is added, it can be based on even parity or odd parity. So after parity bits, if the receiver receives the stop bit, then only total reception of data has been completed in asynchronous data transmission. So as I already told you, to start the transmission, the communication lies in the ideal state. To start the transmission, the start bit low signal like 0 will be moved and indicating that beginning of a frame. Here in asynchronous mode, the data will be set in the frames. The data will be sent in the format of frames. So in synchronous mode, the data will be in the characters like that. Here in asynchronous mode, the data will be moved in the format of frames. So coming to the data transmission, once the start bit has been went, then the data will be moved from least significant bit to most significant bit. If we want to check the errors, then you can optionally add parity bits. That transmitter will add the parity bits, and after transmission, end of transmission will be highlighted by using the stop bit which has been sent by the transmitter. So here in receiver, synchronization will be needed by the receiver and transmitter, so that the receiver can know it can receive received the data. So synchronization in asynchronous mode will be always communicated by the start and stop bits. So that's why receiver will start reception of the data when it gets the start bit. So until stop bit, it will receive the data. If once the stop bit has been received by the receiver, then it will stop the reception. So it can synchronize with the transmitter. Since each frame is transmitted separately and can arrive at any time, so asynchronous mode does not require continuous synchronization, so making it ideal for long range communication. So coming to the next one, synchronous data transfer scheme. Here in synchronous data transfer scheme, the transmitter and the receiver works on the simultaneous common clock signal. Here the clock signal will start the transmission, and the same clock signal will start the reception of the data. So here in synchronous data transfer, the data communication, the master, which is the transmitter, and the slave, which is the receiver. So here uses point to point connection, means synchronization will be there by using the clock signal. Along with that, the multiple devices which can transmit and receive the data. Both devices can transmit the data and receive the data by using the single signal, which is nothing but data and clock signals. Here in synchronous mode, fast and synchronized transmission will be there, because since data and clock share the same bus, so same bus will be used to transmit the clock and will be used to transmit the data also. So there is no baud rate mismatch. So here coming, what is baud rate? So why we need baud rate? Baud rate is nothing but the transmit of bits per second. So if the transmitter is sending 1200 bits per second, the receiver should match that baud rate. So it need to receive the baud rate, same baud rate. So the transmitter and the receiver ensure that the same baud rate is going on. While in the case of asynchronous mode, there might be chance to mismatch of baud rates. Here in synchronous, there is no mismatch of baud rate, because the same clock signal, the same clock and data will be moved in the same bus. So same bus will be using in reception and transmission. So there is no baud rate mismatch in synchronous communication. So it can ensure that it is faster and reliable communication because of not mismatch of the baud rate. Coming to the data transmission, the transmitter side, it will shift the data onto the serial line one by one. So if I want to transmit the data like this, so whenever the clock is applied, then the data will be moved from the least significant bit to the highest significant bit, like most significant bit. So here in this communication, there is no start bit, no stop bit, no parity bit. So the synchronization will always happen with the clock signal only. So the receiver side, the receiver extract the data using the transmitted clock signal and converts the serial data to the parallel form for the processor. So if the processor needs the parallel data, so this synchronization data after reception, it will convert it into the parallel form. So this is the timing diagram of synchronous communication. Here the transmitter and the receiver, see, uses the same clock. So here this is the same bus which sends the data as well as clock. So once the clock applied and the data is in the transmission, then the transmitter sends the data with the least significant bit starting and the most significant bit will ends the data. But here there is no perfect, so there is no stop bit, start bit and parity bit. The data can be, the synchronization always be with the clock signal only. So this is the serial communication methods and modes. So coming to the serial communication standard. So there is one standard protocol used for serial communication, which is nothing but RS-232. The full form is recommended standard. So electronic institutions automation defines that RS-232 is used for connecting data transmitting data from transmitter to the receiver. So it is basically a communication wire or communication standard device which will transmit the data from one system to the another system, or the processor can send the data by using 232 serial communication standard to the other peripheral devices. Here this RS-232 can exchange the data between the two processor or the peripheral devices or two communication devices, and it use serial communication up to 50 feet with rate of 1.492 kbps, so kilobytes per second. And this RS-232 is used for connecting data transmission equipment DTE. So it is used to transmit the data, and the data reception equipment, which is nothing but data communication equipment DCE. So this is the RS-232 standard, which is used to transmit the data between two processors or the processor and the other peripheral devices. So recommended standard RS-232C. Nowadays we are using this RS-232C. So to connect the processor with the other, to interface the processor with the other communication devices, we will use this RS-232C. So in recent version, there is RS-232C, which is having 25 pins. RS-232C is having 25 pins, whereas RS-232D is having 22 pins. Until now, I have discussed what is serial communication, why we are using serial communication, and what are the modes of serial communication based on the transmission, and what are the modes of serial communication based on the clock or the data frames we have been sending. So what is the standard serial communication which we are using to interface the 8086 microprocessor to the other peripheral devices? Thank you.